In this video, we are going to talk about cross products of vectors. Cross product. Is either we say cross product or we say vector product. Vector products. For vector product, the vector product of two vectors leads to a vector. Remember, under dot product, we said that the scalar product or the dot product of two vectors will result in a scalar. That's a numerical value. But for vector product, when we multiply two vectors together, that is using cross product, we are going to obtain another vector. So it is either we say cross product or vector product. If I have two vectors A and B, two vectors A and B, the cross product or the vector product of A and B written as A times B. This is for cross product. Okay, this is it. A times B is equal to the product of the modulus of A, B, and the sine of the angle between the vectors A and B. So here we have theta as the angle between the two vectors. The cross product of A and B is the modulus of A times the modulus of B times the sine of the angle between the two vectors. Alright? Now see this. If I have a vector A that is equal to AI plus BJ plus CK, and vector B, that's capital B, is equal to, let's say, DI plus EJ plus FK. All right. What is the cross product of A and B? This is it. The unit vectors I, J, and K, we have them here. I, J, and K. The coefficient of I here, we have A, D. All right, A and D. A and D. Of J, B and E. And of K, C and F. C and F. So, we'll now evaluate this determinant. This is the determinant of a 3 by 3 matrix. So, we are now going to evaluate it. So, let us find the cross product of these vectors A and B. Okay. So, the cross product or the vector product of A and B is this. Going by this rule or this principle, we have the unit vectors in the first row, I, J, and K. Okay. And then their respective coefficients. We have 2 here, and it is 1 here. For J, we have -3 and +4. And here we have -1, -2. So we are going to take the determinant of this matrix now. So this is an opportunity for you to learn how to determine the determinant of a 3 by 3 matrix. That's if you are not used to it, if you don't know it before. The first entry there is I. Then this is it now. Eliminate this first row, eliminate this first column. What do we have left? This is what we have left. -3, -1, 4, -2. This is now a 2 by 2 matrix. So we evaluate the determinant of this 2 by 2 matrix. Now we are done with this first part. The second entry, that's the second element in the first row, is J. So we have J here. Okay, so eliminate this column, eliminate this row. Alright? J is in this row, the first row, so eliminate it. J is in this second column, so eliminate the second column. Then we'll take the remaining entries. Alright? But take note, the sign associated with this I is a plus, associated with this J is a minus, associated with this K is a plus. So that's why it is plus here. J has a minus, minus J. Alright? Then the remaining entries, 2 minus 1, 1 minus 2. 2 minus 1, 1 minus 2. Okay, so plus k is positive there. Take note, plus minus plus, minus plus minus, plus minus plus. That's how it is plus here, minus here, and plus here. Okay, so k is in this first row and this third column. So eliminate this first row, eliminate this third column. The entries that are left, 2 minus 3, 1, 4. 2 minus 3, 1, 4. So this is it. We then have I into, how do we evaluate the determinant of a 2 by 2 matrix? To evaluate the determinant of a 2 by 2 matrix, this is it. Minus 3 times minus 2, minus 3 times minus 2, minus 4 times minus 1, 4 times minus 1. Let me use a bigger bracket. Okay. All right. Minus j. Okay. 2 times minus 2. 2 times minus 2. I think I'm going to erase this right now. I don't think we need it anymore. All right. That's 2 times minus 2 minus 1 times minus 1. 1 times minus 1 plus k. 2 times 4. All right, minus 3 times 1, or 1 times minus 3. 1 times minus 3. This is 6. Okay, 6 minus, this is minus 4. 4 times minus 1 is minus 4. Okay, so the minus will intercede to give us a plus 4. Minus j into, this is minus 4. Minus, we have minus 1 here. 1 times minus 1 is minus 1. Times this minus 1 outside, that was a plus 1. Plus k, this is 8. Minus, this is minus 3, right? 1 times minus 3 minus 3. Okay, times the minus outside, that will be a plus 3. So we have 10i. Minus 4 plus 1 is minus 3. Minus 3 times minus j is plus 3j. 8 plus 3 is 11, times k is 11k. This gives the vector product of the two vectors. Okay, let me write the vectors again. A is 2i minus 3j minus k. B is 1i, that's I, 4j. Okay, take note, this plus minus are not needed here. All right, 1 times I, 4 times j, minus 2 times k, minus 2k. So these are the vectors that we are considering, and this is their cross product or the vector product. If p equal to 4i minus 3j plus k and q equal to minus I plus 2j plus 3k, we have to find the cross product or the vector product of p and q. Okay, let's go again. The cross product of p and q is this. The unit vectors I, j, and k. Okay, so let's write the coefficients now. 4 minus 1, right? Minus 3, 2. 1, it is 1 here, the coefficient, 3. Okay, so this is the 3 by 3 matrix. We are going to evaluate the determinants now. So the cross product is this. The first element here is I, which is positive. I has a plus, that's plus I. Then if you eliminate this first column, and eliminate this first row, we'll be having just this left. Everything here. Minus 3, 1, 2, 3. Minus 3, 1, 2, 3. Okay. Then minus j. Okay. J has a minus. Minus j. Eliminate this column of j. Eliminate this row of j. So we'll be having 4, 1, minus 1, 3. 4, 1, minus 1, 3. Then plus k. Eliminate this column of k. Eliminate this row of k. Okay, we're having 4, minus 3, minus 1, 2. Good. So we have this I into minus 3 times 3 is minus 9. Minus 2 times 1 is what? 2. Minus j into 4 times 3, 12. Minus 1 times 1 is minus 1. Okay, so minus times minus 1 is plus 1. You get the point? Plus k. 4 times 3 is 8. Minus 1 times minus 3 is plus 3. Minus 9 minus 3 is minus 11 times I, minus 11I. 12 plus 1 is 13 times minus j, minus 13j. 8 minus 3 is 5 times k, that's plus 5k. So this gives the cross product or the vector product of P and Q. Alright, so this is it for vector product, cross product. I hope you like the video. Keep supporting by subscribing to this channel. Like and share the videos to your friends and your classmates as well. I will see you in the next video. Keep following.